We would now like to invite, this is now back to our regularly scheduled program, I suppose that's the feeling I have. We now want to sort of talk a little bit about cures and things like that, and how to do this, who should choose. So could I ask Jay Flatley, Rosalynn Gill,
Gill.
Do you have the list? Do you have the list? I think.
Yeah, Dr. Lupski.
Yeah, Jim Lupski.
Gill, Misha, if you could come up, and Esther, and Dr. Kim. I think that. Yeah, I think that's. I don't know. We'll pull other people up.
Yeah. So this morning we talked about a lot of the burdens. We now want to talk a little bit about the benefits, but because Carl and I are reporters, we just generally don't get enthusiastic about anything if we don't have to. So we just want to try this a little carefully. First of all, just to the group, I noticed that some of these companies, Sionna, Navigenics, DNA Traits, HairDX, they're not doing that well. I mean, the companies that are out there in California have gotten letters from the health department saying cease and desist in certain ways. So I guess asking all of you, in order to make this popular, if we're not doing it in Skip's way and going back and telling stories about our own ancestors, one of the things that Americans like is they like something quick and fast. And Jay, for example, you were talking at some place about, I'd love to read this. Let me see if I can. It was some kind of handheld device that would allow you to do an assay of some kind. And you said, this is a prototype iPhone app. It could be over social networks. It could be in a bar. I think wireless is the way it's going to go. So I'm trying to imagine here. You think that somebody would just have a telephone and go, let's see what my dip, 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 and then or maybe if he sees a girl he likes, he says, can I just ask you a couple of questions? What were you thinking?
So the iPhone application we showed last summer was for the analysis. It wasn't for actually doing the sequencing.
Oh, okay.
And we've taken that now and we've moved it over to an iPad application. So we now have a prototype application that runs on an iPad where you can load your genome and begin to explore your genome on an iPad. It's a tremendous device, portable, and lets you selectively share it, and you might want to share it with your physician, maybe with your pharmacist if you're getting a prescription. And we think it's the way of the future, that people will have the ability to carry and manage their own genomes.
Because it's fast?
What's that?
What do you charge for that?
We don't charge anything for it at the moment. It's not something we put out publicly. It's something we're working on internally, and it's we're trying to get it right before we put it, say, on an app store, because there's lots of issues associated with, if you build a pedigree, do you put in your family information in there, and do you put in information about third parties into this device, and what happens if you lose it? And so we're thinking about all the underlying issues, but it's fascinating to begin to work on this because we think that's how it's going to go, but we want to get it right.
Rosalynn and Esther, you have both been associated with companies that have gotten slapped by the state of California for, I guess, I think they did a sting on some of these things and said, well, no, you're giving, well, I'll just tell you what the rumor is and you correct it. I don't know if it's a rumor, it's what I read on the internet. That some of these services, they say, okay, we're going to give you some nutritional advice, and you send us your DNA, and we'll tell you what you should eat or shouldn't eat or something like that. And the state of California said, I don't know, this doesn't work well enough to suit our sense of what's accurate and what's right, so stop it. And I think some of you have and some of you haven't. But are you worried about execution of this, of getting it right, as Jay just said?
First of all, I need to let you know that Sionna is no longer operating. It ceased trading in April of last year.
Oh my God.
Yeah, so,
okay.
and I guess to finish the sentence, it was really due to a lack of access to capital last year in the economic meltdown, not due to a lack of consumer demand. So, full stop. Now, with respect to the regulations, both at state and federal level, I think that what we're really crying for is some clarity in the regulations. And so with genetic testing, what is medical, what is health related, and who determines where the regulations fall? So with the state of California, yes, from the state of California, from the state of New York, and from the state of Maryland, by the way, we got cease and desists because we did not have state licenses. Now, why did we not obtain state licenses? It was because, according to us and according to our legal counsel as well, the services that we were providing did not fall into a medical category, and therefore we believed that the regulations did not apply. Now, the state regulators felt rather differently, and so before we ceased trading, I'm happy to say that we did obtain a state license for the state of California and for the state of Maryland, and we were a long way down the road with the state of New York. But I guess my message to you, that was a long-winded explanation, I'm sorry, but my message to you is that what we really need is regulatory clarity.
Mm-hmm.
Our story is slightly different, but the basics are the same. We have been extremely careful, and I think unfortunately so, not to give people advice. We give them data, we give them explanations, we give them information about themselves, but we're, just like I was meeting with the head of MyZeo yesterday, the sleep monitor. They have the same problem. They can't give you medical advice, and you have to kind of lean over backwards. So they don't say this is a good amount of sleep. They say this is the norm. And then they also say many doctors think the norm is below what is good. So we got letters also from New York and California. We hired a doctor to do prescriptions in California. It's not that in California they didn't even want us to offer the service without having a doctor look at, quote, every patient before they received this. Kind of like you can't talk to God yourself, you need a priest. And the Bible is something that you should do only in church. We kind of believe everybody should have access to the Bible. But just as Gutenberg was heretical in his day, so are we. To us, the issue is access to your own data. In New York, legally you cannot spit into the tube. So if you buy it in New York but you promise you'll spit in New Jersey, I believe you passed the law, the legal test. Don't write this down without checking the fact, but I think that's the situation. So I think it's unfortunate because people are deprived of useful advice. Going to see a doctor if you get something medical, going to see a doctor before you start taking a drug, obviously, is very different from looking at your 23andMe profile and saying, wow, I should really be careful about what I do with my eyes.
We have a couple doctors here. I'd be sort of curious to find out what you think about whether this sort of information should just go straight to people or whether they need a doctor to intervene.
You're the doctor.
Well, I should disclose that I was on the scientific advisory board of 23andMe.
Well.
They recently disbanded the scientific advisory board, but I believed in at least trying to make it be done right if it was going to be done. There is some information that's probably useful to have a medical doctor in between try to interpret it. And I think part of the problem is we're still learning, trying to learn what all of this information really means.
Well, when Jay asked his doctor to write the prescription, if there was going to be a prescription, your doctor said, no way, right?
That's right. My
Why?
General practitioner.
Yeah.
Because he didn't know anything about it. So I went to see him and told him what we wanted to do, and he said, I don't know enough about this, and it feels a little uncomfortable to me, so I'm not willing to do it.
So he was doing the correct thing as far as I'm concerned. As a professional, you shouldn't be writing prescription if you don't know what you're doing.
You were asking him to
He
do
admitted
what?
it, at least.
A prescription for what?
So in our consumer sequencing business, the way we set it up, we spent about a year working with our ethics committee on how we design the process itself. And part of that process requires the consumer to get a prescription from their doctor to get sequenced. And that's to address exactly the issues that Esther brought up. We philosophically agree with where you and 23andMe are on this point, but we want to establish...
Which is to say, you say no doctor's necessary, and you say doctor's necessary?
No.
Just because to follow the rules.
We're saying that we think the most robust process from a regulatory perspective and a safety perspective is to have a doctor involved. And it's a little different in sequencing where you're talking about doing tens of people versus tens of thousands of people at a much lower price. And so we had the luxury of being able to have a doctor involved. So everybody's required to have a medical geneticist write a prescription. The data are delivered back to the medical geneticist, not to the consumer.
And we fundamentally think doctors are really good as doctors when you need them, but we don't think they are necessary. You know, to some extent, we're starting as an educational company. We think this is people's own data. They have the right to look at it. The advice we do give them is if you have any questions, go see a doctor or a genetic counselor. Unfortunately, there aren't enough of them in the U.S. And so giving people...
Or they may be there and shrug, as
yeah,
Jay's did.
right. You may go to a doctor who says, I don't like this. And
Or no,
yeah,
just say, I don't know.
well, I guess the point is, in a perfect world, everybody would have a very wise doctor who would give them advice all the time. But given that we don't...
Played by Robert
it-
Young on television.
Yes. It is our data. And if you have questions or you're about to do something medical that might be harmful or dangerous, you should absolutely consult a doctor. And let's hope you find a doctor who knows what he or she is doing. But
in the meantime, we have the Wests struggling through huge amounts of data at their kitchen table, trying to figure out what this all means, and taking quite a long time to do it.
Right.
And you know, and these are people who
Yeah.
probably do it pretty quickly compared to
Right.
the rest of us.
And so they know more now than they did before. It was their right to learn more.
Oh no, I agree, but that's probably going to be a very atypical experience.
Right. And that's why, you know, we're not, it's going to take time. So people should start learning more now, because 10 years from now, there'll be
Right.
much more to know. So if they start now,
Yeah.
they'll be better informed 10 years from now.
I just want to first here, because just to interject here. So Rosalynn and I were talking at the break, and she had expressed a concern, I think is a good one, that maybe in talking about sort of unveiling this data, this information, we might have ended up being a little deterministic. You use that word, deterministic. And so what's the sort of the balance here in terms of, you know, looking at this genome data and remembering that this is not...
Deterministic meaning that your genes rule your
Your
future.
genes are you.
Exactly.
So one thing we do in 23andMe is we have a little chart, and it says type 1 diabetes, I think it's 70% genetically determined. Type 2 diabetes, 20 to 25%. And we make it very clear how much your behavior affects
Right.
whether you will get a condition. And we, you know, it's like, as I said, explaining not just genetics, but statistics to people. If you have a 50% greater chance of getting something, and the average chance is 1%, that means 1.5% chance, not a 51% chance.
Oh, so in order for people to understand this product, they're going to have to understand genetics, and they're going to have to understand statistics.
Which is why we give them pictures and narrative and text and all this other stuff. Because,
Okay.
yeah, it is, but I guess I really respect people. And if they can understand statistics about the Red Sox, I think they can also understand statistics about their own genetics. And they're more likely to understand it if it's their own data than if it's some textbook somewhere.
So Rosalynn, what,
Not this season.
Right.
maybe you could sort of expand on what you were talking about before.
Well, I guess when we were going through the morning session, my takeaway was, wow, we're back to you find out about your genes and everything is revealed. And I really want to point at that E and say there is a whole environmental component that's a very important part of what happens. And so I just want to make sure that we don't leave that message behind. Yes, I have my whole genome sequence, or most of it anyway. If I think about my family history, these are cancer, heart disease, multifactorial traits with very high environmental components. And I look to what happened to my parents, my aunts, uncles, et cetera, and I know that my lifestyle is very different. So yes, I'm armed with information, but I'm able to make choices so that my fate doesn't end up the same as my genetic ancestors.
Well, I wanted to ask Jim and you, Misha, I wanted to ask, if it's as hard as it feels like it's going to be, I mean, like if you have to learn a lot to understand anything, are we over? I mean, do you feel a little humble in it? I mean, this is a business which is trying to be helpful. This is a business which is trying to be enlightening. Skip can do that by telling stories that everybody understands. That's my mommy, that's my grandpa. But these are harder stories to find and harder stories to tell yourself. And maybe even they're too hard for doctors or for lapsed genetic counselors who never even tried.
Be gentle.
so to speak.
Well, what is too hard? I mean, this is the thing, is when I was up here before with the Wests, and there was this kind of, well, you know, why did you do this? And this sort of implication that they had burdened their children somehow. I think we lose track of the very sort of generous and altruistic thing that they did as a family for science, because we learn from Skip and his father and people like the Wests, we learn about inheritance in 3 dimensions, about mutation rates and gene expression. So George showed a slide of Hugh Reinhoff, whose daughter has a genetic condition, and thanks to Jay's company, has looked at gene expression in him and his wife and their daughter to look for differences between parents and child. So, you know, I would segue to Jim Lupski's story, which I think touches all of these things.
Well, there you are.
But to respond to that, and your also question of humbling, I think it is quite humbling to think that for 90 to 95% of the human genes in the genome, we have no clue what their function is right now. Okay? So that even when we see a change in Jim Watson's genome, we don't know what the gene does for 90 to 95% of the genes we're dealing with. So that in and of itself is a challenge. Furthermore, coding sequences and the genetic code only helps us with 2% of the genome. 98% of the genome is not coding. So we've got a lot to learn, is what I'm saying. So should fear stop us from learning? I hope not. I hope we can move forward. And I'm not a deterministic type person, even though I am a clinical geneticist. But as a clinical geneticist, I'm most interested in what are medically actionable alleles. I can see all kind of variation in the human genome, but what is the variation that I'm going to want to make a medical decision based on?
So let's get to your story.
Could I add one point? I think we do need to remember that genetic tests are done every day, and very important genetic tests are done every single day. In most of those cases, neither the physician nor the patient understands the underlying technology. And the physician isn't opening a browser to look at a factor 5 result. That has been abstracted in a way that creates actionable information for the physician and the patient. And that's the responsibility we all have, is to take now, from what's today a drip to going to be a fire hose, and figure out ways to abstract this massive set of data we now have access to and make it something that physicians can act upon. And that's really the goal.
Yeah, and by the same token, I don't think that as physicians we should be paternalistic and decide what information people should have available to them. We have to tell them what the state of the knowledge is at this point, but if they want to have that information. And in fact, in the academic journals, in TIGS, this issue, Trends in Genetics, that just came out, Amy McGuire, who's a medical ethicist at Baylor, and I wrote about personal genomes and what should we tell the patient, where we've sort of outlined some guidelines as to why they should be told everything you know, and more importantly, what you don't know.
Well, let's get to what you don't know. So who is Charcot-Marie Tooth? What a name.
Well,
Charcot-Marie Tooth.
Actually, to show you the divide between sometimes medical ethics and institutional review boards, I'll never forget 25 years ago when I first got my first protocol approved by the IRB, and it said, you are now approved to study Charcot-Marie tooth decay. Okay? But Tooth, actually, Howard Tooth was a British physician who graduated from Cambridge University in 1886. And this was his MD thesis, and simultaneously Charcot and his student Pierre-Marie published the same year the description of this condition. And Charcot has many famous fellows, Babinski, of the Babinski sign we do an exam on, Sigmund Freud, who became so interested in Charcot's work on hysteria that he began the field of psychiatry.
So Charcot is a person, Marie is a person,
Yeah,
and Tooth is
Pierre
another
Marie
person.
was Jean Charcot's student.
So they could be
and
a law
Howard
firm,
Tooth.
really. Charcot, Marie, and Tooth, if you want.
But often in medical genetics, we call this eponyms. The disease gets named after, eponymically, who described it.
Right.
In fact, currently there's something called Pataki-Lupski syndrome, after having described that syndrome, too.
Well, what about, so tell me what happens. You and 3 of your 7 brothers and sisters have a problem.
Right. So Charcot-Marie-Tooth disease is a neuropathy, so the nerve doesn't fire correctly, and this can lead to secondary atrophy, particularly in a distal symmetric way, and the feet become affected first.
In English, that means that your brain is going to send a signal to your toes are going to receive the signal and send something back, and somehow the wire is broken.
wire is not working right.
Huh.
And over time, that then leads to atrophy of the muscles that are not receiving
So
the
this is a
proper
foot
input.
problem?
Well, foot, but eventually of hands, distal. So the longer the nerve is, because the nerve from your feet has to go from your spine all the way down to your big
So
toe.
can you, like, snap your fingers?
Yeah, I can snap my fingers, yeah, but there's certain things I can't do.
What can't you do?
Well, I'll run a marathon.
Whoa.
We can't either.
Yeah,
But
that's
my-
not very impressive.
But my brother, who doesn't have the mutation, who's almost 60, always comes out running a marathon in New York and Boston and amongst the tops.
So that's like the Simpsons kind of thing. But what about, so you and your brothers, because you don't use your feet the way the rest of us do, your feet get bad at being feet, and then...
Well, there's a little bit more to it than that,
Well,
but
I imagine.
basically you can get deformities that require a bunch of orthopedic intervention surgeries.
So how many orthopedic intervention surgeries have you had?
Over 10.
10. So at some point you get interested in this, why not? And you also get interested in him, oddly enough, in Jim Watson. So are you a sleuth? What is your job by day when you don't have foot problems? You're a genetic sleuth?
I mean, now I'm a medical geneticist,
Okay.
and I run my own lab.
So the question is why is this happening? What's causing it?
Exactly.
So how long ago did you start to try to figure out what's causing this problem? 10 years ago?
About 30 years ago.
30 years ago. And what do you now know?
Well, now I know the problem because of whole genome sequencing.
And that took the 30 years. Was it one success after another?
I would think that we learned something over those 30 years
Yeah.
about genetics. I think we, particularly the first genetic lesion causing Charcot-Marie-Tooth disease turned out to be a copy number variant, something we never appreciated as being important to conveying human phenotypes. And now that's turning out to be very important, and all of us sequencers have to remember that. It's not all in the base pairs. Don't mean to offend you, Jim. It's not all in the base pairs. The copy number can be extremely important.
Is that something that is sometimes overlooked in genome sequencing?
Yes,
Exactly how
it
many
is.
copies are sequenced?
Sometimes overlooked in genomes.
So Carl will have to help me here. But
And in companies like Navigenics and 23andMe and Decode Me and et cetera, et cetera.
in layman's terms, let me see if I get a sense of the problem here. Many people think that if you're looking for a genetic error in you, or a combination of genetic errors, you look in one place, and then in 2 places, and then in 4 places, and then in 6 places, and there are pathways there are causes to find for the result that you're experiencing. But what if you find 4 possible causes here, another 6 possible causes here, another 12 possible causes here, another 3 possible causes here, and some of the possible causes here sometimes with the possible causes over there, giving you an exponential number of causes. At some point you can get lost in the woods looking for the culprit. And I get the sense that during these 30 years you were in the woods a lot.
Yeah, I mean, I think we were involved in several of the genes and pathways that led to understanding of the disease, but I still hadn't found the mutation that was important in my family. And I think Charcot-Marie-Tooth disease has turned out to be, like Jim had mentioned, for schizophrenia. There's not just one way to get there. I mean, to propagate a signal down the nerve or for the synapse to work properly, For CMT, we know at least 40 genes now. In one family, it's one gene. In another family, it may be a different gene, et cetera.
So what if you were, what's the name of that detective who wears the raincoat and is always smarter than
Columbo.
Yeah. What if you're Columbo and you have 3 suspects, actually 12 suspects, actually 30 suspects, 12 of the 30 might be in cahoots with 3 of the first group. How do you go about solving the crime when everybody looks like he's a suspect?
Well, I think this is where actually I believe genome sequencing will turn out to be even more important from a medical standpoint, is now that we see the way disease phenotypes happen, schizophrenia, autism, Charcot-Marie-Tooth disease, et cetera, and it can happen by many different genetic ways, we're finding that a lot of the single gene testing has transformed into panels of testing, and you're not going to sequence 20, 30 genes. Actually, the cost of doing that, some panels that I order for medically actionable variants are $8,000 now. So what we will have actually is cheaper to do the whole genome at once and then work out what are those genetic lesions that are important to the patient's phenotype. But also I think we're starting to see more and more that the single gene model doesn't hold up well, particularly in complex traits. And actually it seems that you have interactions of mutations at different loci. And until we do many people with whole genomes, we're not going to be able to really figure this out.
So at this point, you say you have figured out, you think, why at least you and your 3 siblings have what you have?
Well, we got through peer review, so I think we figured it
Or,
out.
well, you've identified these particular loci, but
Yes.
do you understand, how well do you understand how well those genes would normally work, and how well do you understand how they're failing in the case of your family?
Well, I think that it's a recessive disease, so there's 2 mutations, and one is a clear nonsense mutation. So we can use the genetic code to help us there. That's a loss of function. The other missense variant, we really do think has some gain of function properties to it, but we don't have a specific biological assay on that individual variant at this point. But in the context of the family, we were able to see where the variants went because we had the whole genome sequence.
Can you stop this from happening?
Currently you can't, but of the 40 CMT loci so far, there are now 2 where therapy is based on what type of mutation you have. So the duplication we described in 91, now you can regulate the gene expression and completely correct the animal model. So you don't try to fix, there's no mutant protein, there's too much of it, so you just downregulate it with progesterone antagonist, and those drugs have worked in rats and mice, mouse models, and Schering-Plough has phase 2 trials on those drugs for another reason, but we would use them in the patients. In Europe, they're starting to use them.
You and Dr. Kim and Carl were talking during the break. Do you want to, because I know you're working on something too.
Well, I was wondering maybe if you could talk a bit about how you're using genomes in your research in cancer. I believe it was gastric cancer you've been working on?
And before I talked about gastric cancers, maybe I will just give a brief introduction of my experience. And after looking at my genome and analysis data, one thing that popped out, one of the risk factor was age-related macular degeneration.
Macular degeneration.
Yes.
For
So
eyesight.
I have an higher than average so the risk of developing this disease. Probably 10 times is more likely developing macular degeneration. And then interesting is last summer I experienced a sudden loss of my vision for 3 hours, which doctors couldn't conclusively and find the reason for even after extensive tests.
Ha!
Yeah,
I bet you it's because you thought, uh-oh, here it comes.
Yeah.
That was like a panic attack.
Yes.
It wasn't anything, really.
It wasn't anything. But so I wonder whether, that's related to my genomes and genome sequences. But that was pretty useful experience for me because right now I'm diligently taking preemptive the steps in my everyday life to slow the progression and of that the disease is by taking a high dose of antioxidants or and having some regular checkups and also avoiding activities that tend to tend to and overexert my eyes. So, and then funny thing is one of my friends and Johnson advises me that was pretty useful information that, and I have put this LED and LCD in the TVs, but he thinks an LED TV is better for my eyes because they don't produce any UV lights. So,
so you're changing your TV set.
Yes, that's why. So I'm currently persuading my wife to make a switch to LED TVs. From
And your wife is saying, "Hey, it's not my problem."
Yes, it's that's what exactly she said that. But but the funny thing is,
she could have said, "Just wear sunglasses, you'll be fine."
Yeah, sunglasses is fine. Yes, but recently, and we did this. My wife and my 2 kids. So genome sequencing, so it's completed. And it's my interest is whether my kids can have the same kind of problems. It's actually and they're coming from my genomes. That's, but we'll see what happened. But I haven't heard anything that.
You haven't found out yet?
So he's, and John is still exploring. That he's looking at the genomes.
So before I tell you guys to get off the stage, let me just ask you one final question. Given how difficult this is, given how hard it is to understand, given how hard it is to cure, given how hard it is to do all of this, given how overwhelmingly overjoyed this room is there some kind of disconnect here between the people who chose to go to this conference and God, who may have willed that this is going to take a lot longer and be harder to do and understand than any of you had supposed?
Who wants to take that one?
Anyone?
Have you ever
I
worked
think
in a
science
laboratory?
is hard, and anybody who doesn't think science is hard is fooling themselves.
Right.
And here we have a lot of variation that makes us all individuals, and how we're going to figure out the signal from the noise is going to take time.
The more people that get excited, the better, because, you know, scientific progress, it's been said, precedes one funeral at a time. But it also precedes one investigator at a time. And even though the public doesn't do science, I think the public having information, the public getting engaged, the public understanding both what it means and what it doesn't is valuable. I want to tell one short story about the 23andMe Scientific Advisory Board. Originally, it gave us the advice, you should publish data only on completely clinically validated studies that have a confidence level of 4. Then they got their own data, and they started talking about it. And they said, you know, let's do the wilder studies. Let's caveat them properly. Let's say this information is not necessarily clinically valid, but let's not keep stuff a secret. Let's let people know. And a lot of this stuff is bogus. But we point out it's not validated, information will change, and I think that's good.
I want to just say something, because when I was at graduate school back in the beginning of time and we started talking about the Human Genome Project, we were still pouring sequencing gels. And I'll never forget, I went to a seminar where someone was talking and they did a calculation that at our current rate of sequencing genomes with 50,000 graduate students, it would still take us 75 years to get one complete sequence done. And what happened was a lot of investment, a lot of enthusiasm, a lot of people worked very hard. And now we have technologies that we didn't even dream about way back when we started the Human Genome Project. So maybe many of us are still excited because we've lived through what a change could happen.
Well, Jim said at the very start of this meeting that he could not have imagined what. All right, so you leave, and we're going to finish with George and with the Wests.